All right, 7 o'clock. We're live. We are live, not Memorex. All right. Hi, everyone. Welcome to this meeting of the Warren Astronomical Society. I'm Bob Chambliss, and I'm into astronomy. Glad you're here. So I'm your president, and tonight our short talk will be Lunar Occultations by Dr. Gary Ross. Our feature talk will be The Wacky World of Exoplanets and How We Discover Them by Dr. Dennis M. Conti. Oh, exoplanets. Not that I'm excited or anything. Okay, do we have any first-time attendees tonight? We do, we have. Oh, wow, hi, 4 of them. How'd you hear about us?
Tony, right here.
How cool, well, good. Awesome. Well, hi. If you wanna join later on, if you like it, talk to that guy right there. And if any of the members would like to get one of these guys, talk to that guy right there. Okay, we have, let's say, a roll call. As a tradition, we like to go around the ranks and say who we are. I'm Bob Chambliss, president. Dale. Oops.
Dale King, do the editing of the WASP.
David Baranski, treasurer.
Gary Ross. Mark Kenzier. Ken Burke. Dale Park, first vice president.
Tom Servadac. Charlie Strackfine, secretary.
Buddy Spilas. Nancy Banish. Dean Stan. Jim Wallace.
In one card carrying member.
Got mine finally.
Maria, go for it.
All right. Hi, everyone. So for you new guys, we have an observatory at Walcott Mill Metro Park, and that's our telescope and the observatory right there on that thing. Every 4th Saturday of the month, we have a free open house, and we open up, have a star party, and sometimes members bring their scopes. I've seen many scopes on the field, so that's a good event. Let's see. Membership roll call. Okay, WASP wearables. If you'd like to get a WASP shirt or something like that, you can talk to Mark Kenzier. Where's Mark Kenzier? There. And there you can see what's available in our newsletter. We still have 3 calendars available. Amazing. Many of our members are astrophotographers, and we make a calendar. And do we have one there? They do those every year. They are really cool. WASP stickers are also available up there. We are a member of the Great Lakes Association of Astronomy Clubs, and they meet every 2nd Tuesday of the month. If you're interested in planning the Astronomy at the Beach event in the fall, they could use your help. So officer reports. We had an event here on the 25th of January, a planetary alignment event, and it was packed. We had 3 telescopes out front. Thank you, Mark. He was here. We didn't have enough scopes. I was told there were 500 people waiting up in the lobby up here, and we had lines going from the telescopes inside, and the observatory is open, and it had a line, and Mike Narlock told me some poor woman was waiting in line an hour and a half, and it clouded over. But we had sucker holes every once in a while, but we did get to see we got to see all the planets, and it was the first time I used my refurbished telescope at an outreach event, and it was the best seeing of Jupiter I've ever had through that telescope. And I've come to the conclusion that my Dobsonian is great for small outreach events, but when you have a line of 100 people, I want a tracking scope. So I gotta figure that out. Oh my gosh, having to move it every time somebody's in there, and little kids watching it for so long that it goes out of your tracking scope. So yeah, the event rocked. I was told earlier that we may have had actually 1,000 people here, and they want to do it again on Saturday, March 1st. So Narlock said he'd like 4 telescopes. I'm like, well, volunteer organization, we'll see what we can get you, but I may have to reach out to GLAC. But they're again doing it again, and let's support the place. We got to get some scopes out here. So last week, I attended the Global Star Party online, which Adrian Bradley does, and so does David Levy. I've actually never attended one, and I'll probably be attending them from now on because they're pretty cool. So I would encourage you to go look that up. It's you can get to it via YouTube or the Astronomical League's page, but that was problematic. I did YouTube and it worked fine. There's like they do it every week, and there's like 4 or 5 presenters talking about a range of astronomy stuff. The reason I attended it last week because my boss, Brother Guy, was on, and he gave an absolutely fantastic presentation. It's been recorded, so I would encourage you to go see that too. So he explained, if you ever heard the high seas, he explained where that term came from, and boy, is it crazy. Uh, I am informed by Brother Guy that the next guest at our full moon meetup is the editor of Sky and Telescope magazine. So I'm going to get to meet her, which is pretty cool. The Ford Amateur Astronomy Club is having their swap meet on April 5th at Henry Ford Community College. That's a fantastic event. And if you want to buy a telescope, that'd be the place to go. Or if you want to get rid of a telescope, that'd be the place to take it. So, Dale, first Vice President, Dale Parton, what is going on with presentations?
Hi, everyone. I'd like to say that as always, I need speakers. We're booked up through April, but starting in May, I need speakers. So let me know if you've got some cooking. At our next meeting at Macomb Community College on February the 20th, John McGill will be our speaker. He's a member of the Ford Club. He has made many trips to Florida and possibly Texas, Boca Chica, Texas. I'm not sure about that. To observe and photograph rocket launches. His topic will be up close and personal rocket launch photography. Then when we're back here early March at Cranbrook, our own Bob Tremblay is going to give a short presentation on double stars. And then Rebecca Blum, granddaughter of our own John Blum, will be our main speaker. She'll be giving a pre-recorded presentation on space medicine. She had to go back to school, but she gave this to some other people and it got recorded, so we're going to do that. I don't normally like to do recorded presentations, but she's sort of connected to the club, you know?
She's fantastic.
Yeah. I don't want to tell her story, but she wants to be an astronaut. And she's doing everything she has to do to be a medical doctor as an astronaut. So she has an interesting story to tell. Okay?
That is really cool. I'm really excited about that. All right, Riyadh, you are online, our second VP and Observatory Chair. What is going on at Stargate?
Yeah, thank you, Bob. Hello, everyone. Yeah, last open house was also on the January 25th night as Cranbrook. And we had a stampede. We had
Wow.
well over 100 people, to say the least. I lost count. Sometimes there were 2, sometimes there were 3 deep inside the observatory all the way around the scope. We had a little traffic jam outside the observatory. So it was really, really good.
And it was cold that night.
Yeah, it was cold. It was cold, but people braved it out, and they didn't mind, and they loved it. Looking at, we looked at all the planets, and finally there were a few people left. We closed the night by looking at M42 and looking at some double stars in there. So it was a really good night. Very one of probably the most memorable busy nights that we had in a long time. I think we may get also some, because some people were very interested, we may get some members hopefully out of that as well.
Cool.
So next open house is February 22nd. It's starting at 5:30. So hopefully we'll have another clear night and come on out and let's see what we can do with the 8-inch refractor. Lots of stuff to see and lots of good images to observe. Thank you.
All right. Thank you, Riyadh. All right. Treasurer David. What is up with treasurer? David, this is our treasurer, David Bransky.
Okay, so we got a couple of things going on. So we did do a deposit into the checking account from the cash box because I was just plain carrying around way too much cash. We also did make a deposit to the Paul Strong Scholarship.
Oh, we did.
We did that. We did that this weekend. When we take payments in for to renew memberships and when you purchase merchandise, we can only accept cash or a check. This year we're gonna start talk to the bank to see if we can get set up using a credit card reader. So it'll be a little bit easier for you to renew your membership here.
Get with the 90s.
Yeah, get with the 90s. So anyway, so a couple of other items here. So in our checking account, we do have $23,473. Cash box, we only got like about $1.95. PayPal, we got $762.33. We do have these stickers on sale. They're $1 each, or if you get was it 7 of them, it's $5.
Yeah.
So we got that. We are getting a lot of memberships in. Keep them coming. We'll cash your checks.
Thank you, David. All right. Secretary Charlie Stackpine, what's going on? Sorry, mate. I'm extricating him from the audience here.
Hello, how's everybody doing tonight?
They are lovely.
All right. Have to note that the January meeting notes are published in this month's issue of the WASP. And now I'm going to talk a little bit about name tags. Well, basically, we would be handing out name tags tonight and at the next Macomb meeting and at next month's meeting here. So I'll call out who's here. Eduardo, I got your name tag right here. If you could come on up. Ben Edwards. All right, no on Ben Edwards. See you next meeting, hopefully. Phil Edmonds. No, not tonight, Phil Edmonds. Oh, here you go, Eduardo.
Thank you.
Thank you. Amanda Chargot. Amanda Chargot.
Brian, Rohrkemper.
Brian Rohrkemper. Clement Chargot. Gabriel Anghauser. All right, we'll be bringing these next time. And if you don't have your name tag, and please email me at secretary@warrenastro, and I'll make sure you're on the list. All right, thank you very much and have a wonderful day.
All right, and our outreach guy, Jeff McLeod, is not here, but I pretty much covered what's going on with that. If anybody has done an outreach event, please let him know by emailing outreach@warrenastro.org so we can include that in our newsletter and stuff. Vichalia is not here yet. She said she wouldn't be, but she said the February issue is posted. We're down to the last 3 calendars. The annual mailer has gone out and renewals are coming in. So our newsletter is online. For the new guys, we have a newsletter that has won an award a couple of years ago. She'd win an award probably every year, and this guy edits it. It's fantastic. You should go look at it. So let's see. David Levy is not here tonight. All right. So, all right, going to astronomy at the news. I give an exoplanet update every time. Well, before I got fanatical about exoplanets, I was fanatical about asteroids, and I pretty much still am. And so we've discovered 1,419,655 asteroids, of which 37,618 are considered near Earth asteroids. And I get this bulletin from the International Astronomical Union about once a month, and it has newly named asteroids and stuff. And I look for Jesuits for the Vatican Observatory and stuff. But a name caught my eye. An asteroid was named for Robert Eugene Williams. He was an American astronomer who directed the Space Telescope Science Institute from 1993 to 1998. It was his decision to take the Hubble Deep Field image, which captured galaxies 12 billion years back in time, which showed conclusively that the universe is evolving. So if you've not seen the Hubble Deep Field, that is this guy right here. Let me share that online. Share. No, that is not it. Zoom. Share that. There we go. So that is the Hubble Deep Field.
Yeah.
What?
You said 12 million, right?
12 billion. Yeah, that's the edge of the universe. Now, this was amazing at the time. A few years later, they did a deeper deep field, and they did the ultra deep field, and the James Webb has done the same thing. These things keep getting better and better. And the takeaway from this is that's all galaxies. Crazy. So the guy that directed that got an asteroid named after him, which is pretty cool. So when it comes to exoplanets, we're now at 5832 and 7372 candidates. And HD 2792, a system located 20 light years from Earth, has an eccentric 647-day orbit that crosses the host star's habitable zone. So you've got the star, the habitable zone around the star. This thing goes in the habitable zone, then way out like that. So the environment on that thing would be kind of like hot, cold, hot, cold. So special interest group, that T Corona Borealis, spaceweather.com has that sidebar thing. The values have changed a little bit, but we don't have a nova yet. We do have some sunspots. Share that again. Share that. And go to notes. There we go. That's today's sun.
Wow.
Yeah.
Yeah.
So there's a lot of stuff there. And this data was from the SDO, although the SDO feed, the live feed, is still down. The place where they store that data got flooded a few months back, and they're still rebuilding it. Yeah, what a pity. I depended on the SDO site. So, Riyadh, you must have seen some double stars that night when you were on the 25th.
Oh yeah. So Orion is a wonderful constellation to look for double stars. There are lots of them in there. And coming up open house in February, it's a pretty good time of the year to look for the winter sky double stars, including Sirius B. So we'll look for that as well. And also there are a few challenges that we could look for in the trapezium. So come on out, and hopefully we'll have clear skies and we'll take a look.
Yeah, I'm working on a presentation about double stars, and Riyadh sent me a whole list of stuff, so I'm going to have to go find those. And what I want to do is show you what they look like from the Earth, what you're looking at here, and then use Space Engine to show you what they look like from them, so you'll see their orbits and stuff like that. I got a lot of cool stuff. All right, so if anybody wishes to start a special interest group, great, do it. If you want to do radio, computers, technology, education, light pollution, podcasting, whatever, go ahead and do it. Let us know about it. And we'll get you published and up on the website and stuff. All right. Any observing reports? Astro photos? Anything? Back when we were in COVID and doing this all the time, people were doing a lot of astro photos online. Anybody have any astro photos at all? Sigh.
So finally, in Western Michigan, there's no point.
All right. Well, it is 7:20.
Yeah, I did see something the other day.
What'd you see?
I can barely see it, but the moon is really close to me. Yeah, I'm seeing it. It's a good pulse. And it was the post when I posted in Elders.
I saw a picture. I wasn't sure. Were they both crescent? Well, Venus is a crescent, but what was the moon a crescent?
I hear it really close. I mean,
That's cool. Oh, Michael Dowd was saying he saw the moon and Venus. They were very close to each other. And Saturday night, I will try to find a picture of that. I'm sure there's one of those online.
a good pulse. Maybe someone in Florida took pictures.
All right. Well, we're a bit early, but we're going to take snack break now and come back and let's do a half hour. Let's do 20 minutes. So that would be 7:40. Let's say 7:45. So go get a bio. Go get us a munchie. Talk to your friends about astronomy and space science and come back at 7:45. Pardon me? All right, I'm screwing up my schedule here. Yes, we are doing the short talk first. Gary, you want to? Okay, let me get this up here. Sorry. All right, so I am going to slideshow from beginning. He's on there. I gotta share it. Share that.
So senior.
What is that sort?
Thank you. Rename this. Rename.
31 for that.
SS. Change.
Short top.
All right, so there we are. All right,
We're good to go.
we're good to go.
Okay, you guys, we're gonna have the short presentation before we do the snack break.
Talks first, everybody. Have a break. All right.
Okay, so our speaker for the short presentation is Dr. Gary Ross, one of our senior members. Gary tells me that he's the longest running attendee at our meetings beginning in early 1962. Anybody here been coming that long or longer? I guess you got it, Gary.
Diapers.
Half of these people weren't even zygotes.
And he did his first astronomical observations in 1958 with his father's binoculars. That was the year he first attended the Detroit Astronomical Society. He helped build the Veen Observatory on the other side of Michigan back in the 1960s. He rather proudly tells you anytime you listen that he avoids mixing electronics with telescopes. He tries to stay away from go to, push to, even setting circles. And he stopped doing astrophotography when film went out. Kind of an astronomy hermit of sorts, I guess. And notably, he was awarded an honorary doctorate in astronomy and oratorical arts at our annual banquet in 2023. This topic tonight, lunar occultations.
Well, thank you. Let's see if we can make this. I know how you feel. I do. I feel it myself. I observed my first lunar occultation, not the first known to science, with my brother and my precocious and inspiring cousin Mike. Occultation of Aldebaran in October of 1960. And my telescope, each one of us had a telescope, homemade Newtonians, and mine was a 6-inch f8.5 on a pipe mount. Pipe mount. I don't reckon too many of you have seen one, much less used a pipe mount. My dad made it out of plumbing fixtures. He got it at a local hardware store. And the telescope was mounted on a war surplus surveyor's tripod that my dad might have bought for all of $9 over at Silverstein's. Anybody remember Silverstein's? Hey, good. It's like Mecca. Right? Occultation of a heavenly body is exactly what the word implies, to cover, or as astronomers, we are interested in the covering process and the uncovering process. The dominant body in this case is the moon. There are other occulting bodies, of course, but we're dedicating and narrowing the topic to the moon. Those are the occultations which are easiest to observe, except not as spectacular as solar eclipses, which are occultations too, but are beyond this discussion. They're easily observed if the object is bright. And I recall calling Mark John Christensen's house on an early morning in 1968 as I watched the crescent moon approach Jupiter, and we had not discussed it. So lest he miss this event, I called the house telephone and got everybody out of bed. And Mark John did come to the telephone, and I just said, to the best of my memory, look up at the moon and Jupiter, and hung up. His mother said later that I was one of her favorite midnight callers. There are astronomical implications to lunar occultations, since the moon is the second most important body in man's cosmology. When that body encounters a bright star or planet, this has to have astrological implications. And I'm sure in ages past, centuries, even millennia past, that if a bright planet or a bright star was occulted by the moon, either predicted or unpredicted, this was looked upon as a very important event, a deviation perhaps in the normal course of things for the astrologers, but something well worth noting, because the brighter stars and planets had their own importance in an astrological scheme. And I might note that the Warren Astronomical Society is enlightened enough to have heard the address on astrology that Clayton V. Carey and I gave, which shows that there is a degree of enlightenment in this organization, which does not exist in other societies in the state of Michigan, but I, of course, will not go into names. The occultations address ancient cosmology. Since the moon is closer to the sun and planets and stars, because if the moon were not, the moon would not occult these bodies. And the universe, by extension, could reasonably be very big if the moon so easily covered these distant stars and planets. By the way, in ancient times, there were philosophers of the Greco-Roman school who held that the universe was infinite and not necessarily some glassine globe with stars painted on it. That was a rather recent view. A celestial, sorry. Hairpin trigger. Two key terms from occultation astronomy are disappearance and reappearance, or more clinically, ingress and egress. These events can occur reasonably at any phase of the moon, and so these events, ingress or egress, can be on the bright limb of the moon or the dark limb of the moon. It is worth noting, however, that visually, if ingresses and egresses are on the bright limb and it is a, quote, big moon, it can be difficult to render an accurate visual timing. For instance, Mark John, who is one of our listeners here this evening, made some magnificent photographs, or pictures, I should say, of the occultation of Mars from northern Illinois, and the moon was very nearly full. His pictures are superb, but observing such a thing, naked eye, could be a bit of a job. And therefore, accurate timings in the old days would have been commensurately difficult. The zodiacal catalog, at least until perhaps recent decades, was the most important tool for occultation observing. Robinson, I think he worked out of the USNO, I'm not sure, but he published the first zodiacal catalog in 1940. And this was expanded by a Japanese worker in the 1980s. And to the best of my reckoning, there are now at least 3,400 stars in the zodiacal catalog. And this catalog was compiled for lunar occultation science, or perhaps planetary occultation science, much rarer event. We have lunar motion versus the so-called fixed stars. Now, we all know that the stars are not fixed. They have their own motions, but in olden days, and I'm not going back that far, let's say the 17th or 16th century, the stars are viewed as fixed. A notable exception would be in ancient times and right through to the present day, the motion of Arcturus, which is a high velocity star and is going lickety-split southward. The position of Arcturus has been notably deformed, or let us say changed, since Greco-Roman antiquity, and is heading approximately, well, very roughly south. But the constellation of Boötes, as a result, that is the alpha star in Boötes, is being deformed as the centuries go on. That said, the term fixed stars is now an acronym, but is nonetheless used, well, let's say advisedly. because we don't have to go back too many centuries before the stars were viewed as fixed. How Arcturus was explained, I have no idea. The path of the moon changes because every 18.6 years, the intersection of the moon's orbit with the ecliptic goes completely around the celestial sphere. That is called the metonic cycle, because meton, at least in the Greco-Roman world, was the first to notice this sliding about, slipping about of the lunar orbit against the ecliptic. I have no doubt that the diligent and highly organized Orientals had noticed it at the same time, and it would take a sinologist to study any records or to look into any scholarship about that, which would be either in Korean, Japanese, or Chinese, Mandarin. But I do not doubt that the Easterners had noticed the metonic cycle. They were just too keen to have missed it. There are full occultations, full bore occultations, where the star or the planet completely disappears. And then there are the highly interesting and scientifically valuable grays occultations, which have to be observed very carefully from points on the Earth that have been determined by the cognoscenti who calculate the paths as described on the Earth's surface. It is not easy sometimes to get to a graze site in terms of accessibility, but grazing occultations are fascinating and valuable, not only in stellar science, but in a study of lunar orbit and motions. The moon's orbit, the moon's motion does change. And to work out the degree of change and over what period of time takes some fixed object against which to measure these things. And the occultations, the full occultations, and the grazes are valuable in this regard. Here is what the occultation observer or occultation science or subscience is up against. The lunar limb, in spite of low power views, is far from smooth. Some parts of the lunar limb, depending on the lunar latitude, are smoother than others. But the moon is a rough body, and under high magnification shows it to be just such. Mountains and valleys. Some of these mountains are quite high and are significant deviations from the theoretical smooth lunar limb. On the moon's surface, there are also deformations, let us say mild depressions and raised areas that also complicate lunar occultation predictions and hence lunar occultation observations. And the librations, which is the gross motion of the moon outside of her own orbit. The libration is when the moon will tilt north, south, east, west, ever so lightly as a function of the moon's orbit. And librations allow us to see more than 50% of the lunar surface. Approximately 4/7 of the moon is visible from Earth. But to see all of the 4/7 takes years because the librations are a very slow process. But one can see the difference in what face the moon presents to us in publications such as the Observer's Handbook. And in every month's observation section, they have a table showing how much the moon is librated north or south or east or west. with a little diagram to make it easier to understand. It's quite an ingenious presentation. So these librations also throw, let us say, another variable into lunar observations and the observations of the moon using stellar occultations. Now, well, I almost said I am a man of traditional values, but actually I'm a man whose time has passed him by. Use the old methods when I used to use them. I no longer make lunar occultation observations. That is a long and sad story, and for the price of a pint, I might go into it for you sometime. It is a story of disappointment, confusion, and bad blood. None of it, of course, mine. The first observers were new at this with their new telescopes, and they probably thought that they could count off 1 hippopotamus, 2 hippopotamus, 3 hippopotamus for lunar occultations. That very soon, I'm sure, showed them that it was futile because the event took place so fast. They knew it was really fast, maybe instantaneous by their thinking and by their methods of observation. I'm sure that in the observatories of the Enlightenment, there were observatory clocks. There were also gentlemen astronomers like Hevelius, who came from a wealthy family, who had his own finely made clock in order to time these events. It was not easy, I assure you. I do not know, and maybe we have some savant here who can tell me when stopwatches were invented or made. I don't know. Go ahead. What's the taker?
Well, they did it to time horse racing in about 1850, 60.
In the 1850s or 60s?
Time horse racing. And they're in Kentucky, you know.
Oh, yeah, I've heard of Kentucky, a strange place. Yeah. Now, since they were using to time horse races, I have the feeling that stopwatches of some accuracy or greater accuracy than that existed decades earlier. And I suppose that I could have looked into it, but on the other hand, well, I'm on salary. So, right. But a stopwatch, when they became available, probably in the hands of scientists, really advanced the study of lunar occultations. Because now, well, the beautiful jeweled thing I bought at Oakland Mall in the 1970s is capable of giving to 1/10 of a second, or maybe better. And that's simply a mechanical, it's not electronic. But the introduction of stopwatches was a tremendous advance in occultation studies. Then the real rationalization started with broadcast time signals to standardize this around the world. WWV, out of the National Bureau of Standards, actually started about 1922 giving agricultural commodity prices. That was under, I guess, at the behest of the Department of Agriculture, but very soon turned to broadcast time signals. And to the best of my knowledge, WWV on my father's my father's portable radio, I think, has 4 frequencies. 5, 10, 15, 20, 2.5, something like that. And CHU came out of Dominion Observatory, which was north of Toronto. When the hotshots introduced PEP, photoelectric photometry, with strip chart recorders now we could really see the profile of those events. And I am not a PEP man, so I won't go into it, but I just pointed out as a tremendous advance beyond the ear and the eye and the stopwatch, a tremendous advance in studying lunar occultations of planets and, of course, of stars. I say traditional because now they're using CCDs and God knows what, all of which are beyond my skill or interest. Atmosphere of the moon. This was a great question once telescopes came in. There's no doubt that in antiquity, the moon was regarded as having an atmosphere. Why not? We have an atmosphere, so why shouldn't our sister have an atmosphere? Well, here's what Duncan says. First edition, 1926. Of course, it is on my shelf. He says about the atmosphere of the moon. He says, it is certain that the moon does not possess an atmosphere which is at all comparable to that of the Earth. The star disappears and reappears with extreme suddenness, and there is no evidence of any fraction of light at the moon's limb, as in fraction. Even a rare atmosphere should bend starlight slightly, delaying the disappearance and hastening the reappearance of the star. But the observed duration of an occultation is always equal within a fraction of second to the prediction. And he concludes that the moon atmosphere, quote, if any, is less than 1/2000th of the Earth's. That was the state of the art in the 1920s. I'm sure that there are those in this audience who could tell me what the final or the most recent estimates are. Actually, there has been, this is a digression which I will not beat to death. The astronauts have seen what appears to be locally little outgassings or electrostatic somethings, but that's not an atmosphere that's going to take you downtown for Saturday night. It's not really an atmosphere unless one broadly defines an atmosphere, and I'm not going to get into that. I'm sure I'm going to get hate mail as a result of saying what I just said. The atmospheres of planets, that it is possible with an occultation of a large planet, let's say Venus, Mars, Jupiter, Saturn. And I'm sure that this was done in the 17th century, looking for a sign that the planets had atmospheres, but the planets do not readily exhibit large extended atmospheres, not to the human eye and not to a 17th or 18th or even 19th century telescope. But I have no doubt, and I did not go into the literature because, as I said, I'm on salary. No doubt the astronomical journals of the day and observatory records and correspondence between astronomers would tell of efforts to test what the atmospheres of planets are using lunar occultations. And then there's always the question of unknown satellites. The bright planet is occulted, preferably by the dark limb of the moon, and astronomers could look for satellites, assuming that they had any idea of the orbits of said satellites. I know that that Asaph Hall in 1877 at the U.S. Naval Observatory did not use a lunar occultation to discover the satellites of Mars. He used a good old occulting bar in the eyepiece, which is a devil of a lot more convenient. And one does not have to wait for a favorable occultation. So, Riyadh, double stars, see those words? This is for you, Riyadh. Yes. One can discover double stars using occultations, even with no stopwatch, even with no timepiece. If one is watching an occultation and the limb is approaching the star, and the star goes boom, boom, there are two of them that would have been, say, in 1800, too close together to resolve with the optics that existed. That if a star disappears or appears in steps, that is a good first approximation that that star is multiple. The outer atmospheres of the star is fine. I have no doubt that such studies have been made with photoelectric photometry most favorably, but going back 200 years, I have no doubt that the astronomers were trying to time these occultations to establish the diameters of stars. Regulus is pretty small, and Aldebaran is much larger. And Antares is this big cheese ball. But the distance is more critical, which would then be important in establishing the size of the star in the sky. Actually, the first measurement of a star's diameter was not done with a lunar occultation. It was performed with an interferometer, which was bolted to the 100-inch hooker in 1921, made the Hooker telescope look like a hammerhead shark. The engineering of that and the collimation of that interferometer is probably worthy of a book unto itself, and it may have been written. But front page of the New York Times with a picture showing the hooker with the hammerhead-looking interferometer and establishing the size of Betelgeuse. I'm sorry, it's in Duncan's book. I failed to look it up because he made quite a deal about it, because young John C. Duncan, Professor Duncan, cut quite a rug out at Mount Wilson in his younger years. I'm not saying he was part of the experiment, but it took until 1921 to get the diameter of a star. And it was not with an occultation. So, my goodness. I'm looking at myself in this, and I'm reminded of the words of Oscar Wilde, who said of the picture of Dorian Gray, it looked like it had been eaten by a moral leprosy. Anybody know any jokes? So, I don't know. Yeah.
You asked about the stopwatch.
Yes.
In 1695, a British man called Samuel Watson invented what he called the physician's pulse watch at the request of a surgeon, John Floyd. The device was a pocket watch that could be stopped by operating a lever, was able to measure to an accuracy of 1/5 of a second.
Wow, in 1690s?
1695.
Well,
I was talking about was one that had a speech second again.
1695. That's very impressive. I would have guessed 150 years later than that. But what do I know about timepieces? Well, then astronomers then who were doing occultation studies then had stopwatches of a sort, if one could afford a stopwatch, through the 18th century. And that probably observatories had dedicated stopwatches. I'm glad you came here this evening. I was having my doubts. So thank you. Learn something.
All right, let's give Gary a hand. Thanks, Gary. All right, let's take a 20-minute break and reconvene whatever that is in 20 minutes. What time is it? 7:54. So that would be about quarter after 8. Take a break.
Oh, you do? Yeah. They don't have to be approved. That's the wonderful thing about having all these little eyes and these things. Don't have to wait. That's other stories.
Say, Gary,
Today I am, I guess.
thank you from the Clementine. That is the moon's atmosphere. It is an exosphere. It's probably dust kicked up by the solar wind and impacts. But
The particles on the moon, touching, and then the solar wind comes along.
and impacts constantly kicking stuff up. But yeah, Clementine, they took that. It's about the density of where the International Space Station is around the Earth. Okay, 5-minute warning. Hey, Bob, I have an audience member here asking you what kind of car that is in your background. All right, so let's get this show on the road here, get our main presentation. I'm going to have, hello, we're going to start this presentation. I need to bring my thunder and my big whistle. All right, so our first vice president will be announcing our main speaker. Can't do that.
Well, our main speaker, Dennis Conti, has a very interesting and, dare I say, impressive bio. He's a retired telecommunications professional and an amateur astronomer with a strong interest in exoplanet research. In 2015, he founded the AAVSO's Exoplanet Section, that's American Association of Variable Star Observers. He started their Exoplanet Section. He has worked closely with the TESS Science Team. TESS is transmitting exoplanet survey satellite that's been finding lots of exoplanets. To qualify AAVSO members as official participants in the TESS ground-based follow-up program to find exoplanets in the data. He also developed the TESS submission guidelines and the software for detecting false positives. Dennis is a co-author of over 50 exoplanet discovery papers, and awarded the American Astronomical Society's 2020 Chambliss Amateur Astronomy Achievement Award. So his topic for tonight, the wacky world of exoplanets and how we discover them. Dennis, take it away.
Thank you very much for that introduction. Let me first start by saying that when I went to your website, I was very, very much glad to see at the very top of your website a statement that I have been advocating for the last several years. And let me share my screen and show you what I meant by that. Let me move things out of the way here. On your website is the statement, amateur is not an insult. I totally agree with that. I've been advocating for the last several years that we amateur astronomers are proud of that title. Just a quick anecdote, I was doing a presentation at a professional exoplanet conference, and the conference chairman, in introducing me, was a little reticent to call me an amateur astronomer because he didn't want to insult me. And I said, look, I said, amateur derives from the French word amateur, which is lover of. So we are lover of astronomy, just like all of you in the audience are. So I think that I am in total agreement with what you have on your website, and congratulate you on that stance. So I just wanted to say that at the very beginning. So let me move on to my presentation. Moving from the our solar system that Gary was talking about to the extrasolar world of exoplanets. I'll be talking about not only the different kind of exoplanets that are there, but how we discover them. And by the way, by we, I mean us amateur astronomers in conjunction with our professional colleagues. What you see on the slide here is the artist's rendering of exoplanet LTT 1445AB, kind of a long name. But what's interesting about this, this is life more than imitating art. By that I mean that if you recall in the movies Star Wars, there was the planet Tetion, which was orbiting 2 stars. This exoplanet, which is shown in the lower part of the screen as a rocky terrestrial planet orbiting a star in the upper left, that system itself is orbiting 2 other stars. So life is actually 1 more star than the movie Star Wars. So we are in a very strange world when we're talking about exoplanets. So what I'd like to do is start with the big picture. Rather than getting wrapped up into all the nuances of exoplanets, I think it's important to step back and look at what's the question we're trying to answer, that NASA and all of the missions it's doing is trying to answer. And I think we would agree it's simply to see if there's planets outside our solar system that can support life. Now, to answer that question, there's a series of other questions that exoplanet scientists have to answer. Is the planet rocky? Does the planet support liquid water? Because life as we know it, at least, requires water as an ingredient to support life. Does it have an atmosphere? Does the atmosphere contain biosignatures that we can identify as being indicative of some type of life on that planet? And also, which of those biosignatures can we rely on that give us confidence that life exists on the exoplanet? One of the current large areas of research right now with exoplanet scientists is in fact trying to answer that very question, because professional astronomers are now finding that whereas we thought that some of the biosignatures we thought were caused by biological processes might actually be caused by geophysical processes. So trying to sort out biosignatures that are true signatures of life is ongoing research. So the study of exoplanets clearly helps us answer these questions. Now, exoplanets are everywhere. Most stars have one or more planets orbiting them. So if you look up at the night sky, probably about 80 to 90% of the stars you're looking at do have at least one or more planets orbiting them. Now, of course, we can't see them from our location on Earth, but nevertheless, we've seen from the statistics that we've gotten so far from exoplanet observing that that's probably the case. Right now, there's over 5,800 exoplanets that have been confirmed. Now, confirmed is very important because there's a lot of rigor going into confirming an exoplanet. We'll see a little bit later that there's many candidates, but 5,800 is the current number of confirmed exoplanets. Some exoplanets pass directly in front of their star. From our point of view, we call those transiting exoplanets, and that's going to be sort of the focus of most of my talk. Exoplanets come in all different sizes and orbital orientations, from planets the size of the Earth to planets many times the size of Jupiter. So, for example, one of the most discovered planets in terms of at least numbers are so-called hot Jupiters. Of course, the name comes from the fact that these are large planets, i.e. Jupiter-sized planets, orbiting very close to their host star, therefore hot. This was sort of shook the world of astronomers initially because this was completely unlike our own solar system and resulted in a complete redoing of the theory of planet formation. We have found stars that support multiple planets, many of them in the habitable zone. The most famous, of course, is the TRAPPIST-1 system that has a number of its planets in the habitable zone of its host star. Some planets actually are orbiting a star that system itself is orbiting another star, very much like we saw on the cover slide of the presentation. Some planets are free-floating for various reasons, have been ejected from their system, their particular host system. And some planets are orbiting opposite direction from the rotation of their host star, which is a little curious because when you think about it, as we'll see in a minute, a planet forms with its host star in a circulating circumstellar disk. So it would be natural that the planet's orbit would be in the same direction as its host star rotation. So some of the planets that have been seen to have orbits opposite their star's rotation were most likely captured by their host star. And we've also seen evidence of planets disintegrating around their host star. Some of us were involved in a study a few years ago to help, in fact, confirm that to be the case. So to look at how exoplanets are formed, let's look at the formation of stars themselves. This, of course, is the famous, in fact, I think one of the first views of James Webb Space Telescope showing a star-forming region with dust and gas as the ingredients of the stars being formed. So if we look at how stars are formed, which is this cloud of gas and dust clumping together, creating dense cores within the clumps, where those cores form by gravity pulling together some of the gas and dust, form young stars in these dusty disks. And from that disk, planets then begin to form. So the creation of exoplanets comes directly from the creation of their host stars. Now, in that formation process, some planets form very close to their parent star. Some form at a distance from their host star and migrate inward. Some of the planets may form as rocky planets, such as Earth, some as gas giants, such as Jupiter, and some as ice giants, such as Uranus. So understanding the density of planets, that is to say, whether it's rocky, gaseous, or ice, is important to understanding the habitability of those planets. So how do we know, in fact, if a planet is rocky? Well, as I said, understanding the bulk density is a key thing. And, as you probably know, density is a function of two things, size and mass. That is to say, the radius and mass of the planet. So these are the two measures that exoplanet observations are striving to get, radius and mass. And these typically require two different kinds of techniques. The transit method, which is measuring the dip in light of the star as the planet passes in front of it, gives us the radius of the planet. To get the mass, a technique called radial velocity, which measures the star's to and from movement from our point of view as the planet tugs on it, as the planet revolves around the star, gives us the mass. So once we have the radius and the mass, we get the density. From that, we're able to determine whether in fact it's a rocky planet or not, which is one of the key questions I pointed out at the very beginning to see if it's potentially a habitable planet. So our focus from the standpoint of the kind of observations that we amateur astronomers, and in fact, indeed, most professionals have been involved in, is the transit method. Now, it is biased in the fact that this obviously is looking at only those systems that have a planet passing in front of the star from our point of view, which you can imagine if the orbit inclination is tilted to the point where that transiting planet no longer is passing in front of the star, then the transit method is not applicable. So the point here is that our focus is on those set of systems where the planet, in fact, is passing in front of a star from our point of view. And what you see in this little cartoon is a exoplanet going in front of the star, and underneath the little dots you see are our observations of the flux of the star. And as the planet comes around to the left edge of the star, and as it starts occulting the star, then you start seeing a dip in light of the star until the planet passes in front of the star, and again, the light of the flux of the star levels off. So it's this characteristic curve, light curve, that tells us a lot about the planet. And this is what we amateur astronomers are able to record and observe as we're looking at exoplanet candidates. The type of observations that we're doing, I'll get into later, but involve very much the same equipment that those of you involved in doing deep sky imaging are familiar with in terms of scopes, mounts, CMOS or CCD cameras, filters, and so on. So if we focus in on the light curve and look at a couple of things about it, in particular the duration and the depth, we're able to get a lot of information about the exoplanet. We're able to get an estimate of its size, that's to say its radius, which is a function of its depth relative to the radius of the host star. We're able to get an idea of its orbital size, and we're able to get an idea of its inclination. So from strictly looking at and measuring the light curve, there's a lot of information about an exoplanet that we're able to determine. The shape of the curve, in fact, is very helpful, as we'll see shortly, in determining whether, in fact, this is a false positive. So the characteristic shape is important in that respect. So how do we amateur astronomers contribute to exoplanet science? Well, the first is very simple, which is to help confirm that a transit event occurs. In other words, did we see, in fact, what was predicted at a certain time, a dip in light of the star? I will tell you that a modest-sized telescope in a suburban, even environment, would be able to detect a dip in light of about 1%. I, for example, live in suburban Annapolis, Maryland, and have done many exoplanet observations from my backyard telescope, overlooking somewhat of a light dome over Annapolis, and have been able to do just that. So detecting these transit events from amateur scopes is in fact very doable. So the first thing, of course, is for us to confirm that event took place. The second is to refine the center point. That is to say, what is the time that light curve, the midpoint of that light curve took place. The reason that's important is because, as you can imagine, if we get that point more and more refined, we're able to better predict the next time that the orbit takes place. That is to say, we're able to refine the period. Well, why is that important? That's important because some of the large space-based telescopes like James Webb, where the time is very precious, we want to make sure that when it is scheduled to observe an exoplanet, that exoplanet transit is going to take place at that time. James Webb, for example, is currently doing a lot of atmospheric characterization of confirmed exoplanets. So these confirmed exoplanets better happen at the time they're predicted, so we don't waste any James Webb telescope time. And so helping to refine the center point, therefore the period, is something very, very important for exoplanet researchers. Determining the depth of the transit is another thing that we amateur astronomers contribute to. And as I said earlier, determining the depth of the transit leads us to an estimate of the radius. And finally, helping to rule out false positives. With discovery missions that NASA is doing, and we'll see one in a minute, it's very possible that a space-based telescope detects a transit, but in fact, when we look at it with better resolution, believe it or not, from Earth-based telescopes, we're able to, in fact, determine that no, that's not an exoplanet. It's, for example, might be two eclipsing binaries. And finally, we're able to help determine if there are any undiscovered planets. If, for example, we're measuring the center point time after time, but we see very periodically a shift of that center point, that could be indicative that there's another celestial body that is affecting the orbit of that exoplanet, i.e. that there might be another exoplanet in that system. So these are some of the key contributions that we amateur astronomers have been making to exoplanet science. So what was alluded to earlier is TESS, which is NASA's current exoplanet discovery mission. TESS standing for Transiting Exoplanet Survey Satellite. And as the name implies, it's focused on transiting exoplanets. And by survey, we're talking about it doing a survey of the entire sky, where it has 4 cameras simultaneously dwelling on a region of the sky for 27 days, moving to the next region, and over the course of a year, essentially doing a survey of 80 to 90% of the entire sky. Currently, after being launched in April 2018 and conducting all-sky surveys, mostly focusing on bright nearby stars, one of the key purposes of TESS, as I alluded to earlier, is to help find Earth and super-Earth-sized planets for James Webb to characterize their atmospheres, which in fact is happening right now. So far, there have been 7,300 candidates that TESS has discovered, and we have confirmed so far 604 of those. And this is out of the total of 5,800. So there's plenty of candidates that still need to be confirmed, and amateur astronomers are actively working with professionals to help do just that. And this process of moving from candidate to confirmed is a very rigorous process. And this is where amateur astronomers with our ground-based observations are playing a big role. In fact, if we look at the confirmation process where the TESS satellite identifies a candidate, what happens is it sees a dip in light that looks like it might be an exoplanet, but as we'll see, because of the large pixel size of TESS, there's still some uncertainty if in that pixel there's light from multiple stars that might be confusing the issue. So a candidate is passed to ground-based observing by us amateurs and professionals to, in fact, resolve whether, in fact, that dip in light is caused by the target that we've been looking at, or if, in fact, it's there's some mimicking of an exoplanet transit by multiple stars having their light blended together. So this is the first step in the confirmation process that amateurs are involved in. Once it passes that stage, then there's other further refined imaging done, including radio velocities to get the mass, and what pops out at the bottom is a confirmed exoplanet with hopefully both mass and radius defined, so we have an idea of the density of the planet. So going back to this problem of blending together that might happen in a TESS image, this causes the possibility of false positives. So for example, if we see here a target next that we think might be an exoplanet host star, if there happens to be a eclipsing binary nearby, that is to say, 2 stars eclipsing each other, where from a TESS point of view, though the light of those are blended together, that may result in a mimic of an exoplanet transit. And this is where we have to, from Earth-based telescopes, resolve the two to see if, in fact, there is an eclipsing binary nearby. Now, why are we able to do that on the ground? Well, if I take a look at, in fact, this is an image from my backyard telescope, and if you kind of look at the 2 stars in the middle, and let's say we zoom in on those stars, where each of the little squares is a pixel, my image scale is 1 arc second per pixel. So you can see that the point spread function of a star here goes across, several pixels. On the other hand, TESS's pixel is 21 arc seconds. So TESS's pixel is this big. So from TESS's point of view, its pixel is going to have blended together the light of these two stars. So when TESS sees a drop in light in this one pixel, we need ground-based observing to in fact separate out, is it coming from the star in the upper left, which might be the target star, or is there in fact a nearby eclipsing binary, let's say in the lower right here, that is causing that dip in light. So this is the reason why ground-based observing is needed to supplement the TESS Space Telescope. And as I alluded to earlier, just looking at the shape of the light curve helps us determine whether it's a false positive. It's a bucket-shaped curve that's more indicative of an exoplanet versus a V-shaped curve, which would indicate it's a eclipsing binary. The same with if there's odd and even depths in different wavelengths. And also whether in fact there's variations not only in the depth, but also let's say in a blue and red filter, as well as the depth itself. If it's too large, more than likely it might be a brown dwarf, for example. So the shape of the light curve itself helps us to determine whether it's a false positive. So we amateur astronomers, when we're doing some of these observations, will be asked to, for example, observe, let's say, one night with a blue filter or another night with a red filter, or ideally be able to do it simultaneously with alternating filters. To give you an example of a false positive, this is a observation of a candidate that was taken by some colleagues of mine in upper state New York. And I did an observation in a blue filter. And when you combine the two together, you can see that there's a depth difference. This is clearly indicative that this was not an exoplanet transit, but in fact, this is an eclipsing binary. And so this helped to eliminate that as a candidate. Now, things get very complicated because of TESS's large pixel, that if the target is in the middle, there could be a radius, there could be a radius as large as 2 arc minutes that we actually have to look at. And so one of the things we did was to help develop some software to automate this process, where it was taking hours and hours manually for even some of the professional astronomers to do this. We're able to simplify that in an automated way. So to sort of summarize the contributions we've made, a large majority of the TESS follow-up submissions have been from amateurs. We, as was indicated earlier, we helped develop some of the submission guidelines, some of the software to help clear fields of potential false positives. And we're also helping with looking at observations from some of the professional observatories, such as LCO sites. Routinely, there's a group of us that get observations overnight from LCO observatories in Hawaii, South America, Canary Islands, and so on. So we're looking at images taken from 1 meter, 2 meter dishes, for example, in addition to our own backyard telescopes. So looking ahead where NASA is going, as I've alluded to, the James Webb Telescope is now doing observations in the near infrared to have characterized exoplanet atmospheres. The way that Webb is doing that is not directly looking at the exoplanets, but looking at the starlight that skims through the atmosphere of an exoplanet as it's transiting. And from the spectroscopic observation, it's able to determine elements that are in the exoplanet's atmosphere, because some of the starlight, for example, would have been absorbed by certain elements, and that pattern would be indicative of whether it's water or carbon dioxide or whatever in the exoplanet's atmosphere. The next exoplanet mission that everyone's looking forward to is the Roman Space Telescope, which is currently scheduled for 2027. Currently, hopefully that won't slip. And the difference there is that the Roman Space Telescope will start looking directly at an exoplanet atmosphere as opposed to Webb, which is sort of doing it in an indirect kind of way. Now, it's still going to be very difficult for even Roman, because the contrast difference between the light from an exoplanet and from its host star is so great that even Roman is going to have to look at exoplanets further out from their host star. And one of the things that the Roman Space Telescope is going to be actually doing is testing out a coronagraph to help block out the light of the host star so that the exoplanet itself could be more reliably measured. So to summarize, I think it's fair to say that we have contributed greatly so far to both the confirmation and discovery of exoplanets. Those of us who have had astroimaging experience have found it relatively easy from an instrumentation point of view to move to exoplanet observing. The processes and analyses are different, but the instrumentation is, as I said earlier, very similar to any of us doing deep sky imaging. And it's given us an opportunity to really participate in exoplanet discovery, to the point that those of us who have observations that are part of a discovery paper are invited to be co-authors of those discovery papers. Now, a few words about the AAVSO. We provide the training and software to help anyone who's interested in obtaining skills to do exoplanet observing. We are an international organization that have been around for over 100 years. In fact, I'd say we're probably the oldest amateur astronomy organization in the world. And we do that through pro-am collaborations, TESS being an example. We archive our observations on databases that we manage. We're doing one, in fact, for NASA for a project they have to help confirm and refine the period of confirmed exoplanets. And we have a journal that publishes the results. It's a referee journal of some of our members. We provide the tools and training to do what I'll call science grade observations. We have an annual meeting where we get together and share our experiences and observations. And we have sections. This is the core of the AAVSO, where we have sections that focus on different aspects, ranging from cataclysmic variables to eclipsing binaries to, of course, exoplanets, which is my area of interest. So that's a little bit about the AAVSO, of which I'm a member and currently lead of the Exoplanet section. And finally, let me just say that some of the training resources specifically on exoplanets, we offer courses. In fact, I'm starting one a week from today that will be an introduction to exoplanet observing. Unfortunately, it's already filled, but I'll be doing another one also. If you are interested, you can go to my website, astrodennis.com. You'll see a link to a practical guide to exoplanet observing, which is a document that provides the best practices for exoplanet observing, as well as a step-by-step guide through a free software program called AstroImageJ, which is the sort of de facto exoplanet analysis software used by amateurs and professionals. And we also have a qualification program that any of our members who are interested in participating in the TESS program, we have an agreement with TESS that if they go through our qualification program, they will become a member of the TESS team. So just wanted to wrap up with that, and anybody who is interested in joining our Exoplanet section, you can email me at dennis@astrodennis.com. And if you visit my website, you'll not only see a link to that guide I mentioned, but I also have on there sample images of an exoplanet that actually is used in the guide as an example. So literally you could download those images and in the guide walk through step by step as if you're doing your own exoplanet observing. So with that, let me stop and see if anyone has any questions. Anyone with questions?
Video. Try it again.
Sorry, the first question was, what are your thoughts on Pluto as a planet?
Personally, I was really disappointed when it was demoted, but I understand that the Pluto is viewed as one of many minor planets, I think is the politically correct word now. So yeah, I mean, it's a planet. It's a planet, but whether it's a minor planet or one of the 9 planets, that's up for debate.
Okay. Yes.
What operating system is required for the software?
What operating system is required for the software?
Runs on anywhere from Windows to Apple computers to Linux. So,
Other questions?
Is Jerry Persha part of your program?
I'm sorry, what is it again?
Is Jerry Persha part of your program?
Jerry Persha.
The name is not familiar, sorry.
All right, well, that answers my question.
Any other questions? Yes.
First exoplanet discovery.
How long ago was the first exoplanet discovered?
I'm sorry, what was the
19
question?
How long ago was the first exoplanet discovered?
Well, let's be clear, there was an exoplanet discovered that was part of a pulsating star, neutron star. But if the question is a exoplanet around a sun-like star, that was about 30 years ago. Let's see, 30 or 40 years ago.
51 Pegasi?
Exactly.
95, wasn't it?
Yeah, so about 30 years ago.
Actually, there's some evidence that they may have found evidence for an exoplanet in a 1917 white dwarf survey, but it wasn't recognized as such.
There's a question in the chat.
Any other question? Oh, a question in the chat?
Let's check.
The question is there a section of our galaxy richer in exoplanets? I don't think so. I can't. I know that the Kepler Space Telescope focused on Cygnus, and so it's sort of biased the count of exoplanets, that 5,800 count is kind of biased by the fact that a lot of them were from the Kepler Space Telescope, which just focused on one particular area. TESS, fortunately now is doing an all-sky survey. So I would not say that there's offhand. I can't say that there's one area richer than others. I will say it's a little bit more difficult finding exoplanets. If you think of the ecliptic plane in terms of looking through the middle of the Milky Way, just because of the density of it and how crowded it is. But I don't think there's, except for observational bias, I can't say that there's one area richer than others.
Anyone else?
You've come a long way since Peter van de Kamp at the Sproul Observatory.
Since what? I'm sorry?
He says you've come a long way since Peter van der Kamp at the Sproul Observatory.
Sproul Observatory.
Yeah.
With his refractor. He was working, I think, in the 1930s. And they had a problem with instrument bias. So, to the best of my knowledge, Van de Kamp at Sproul was the first North American worker to attempt to find an exoplanet. And it did not work out.
Okay. Well, look, I think this has been a fantastic presentation. I had no idea of how large a role amateur astronomers have been and continue to play in this really interesting field. It's amazing to me. I thought the professionals are taking over. It's getting to be very difficult to do any original contribution. This is frankly amazing. Thank you so much for your presentation.
Yeah, my pleasure. Thank you.
So our next meeting is in 2 weeks on February 20th at Macomb Community College South Campus. Our next star party is 2 days after that, the 22nd, at Stargate Observatory. Some of us head out and do gastronomy at the Redcoat Tavern after this, Woodward, north of 13 Mile. And with that, pardon me? Snacks volunteer. I need a volunteer to bring snacks at the Macomb meeting next time. Anyone want to volunteer? I'll be sending out an email to the membership then. Okay. All right. Well, anyway, with that, good night, everyone. Clear skies.
Thank you.
And thank you. Thank you, Dennis. I am shutting down. Good night, everyone. Shut down.